Then after that, maybe we have about 5 or 10 minutes break. In the second session, another 50 minutes to 1 hour, I would like to talk about the diaphragm wall. So let's start from the bolt piles with the Bauer BG system. I think this photo is very interesting. In fact, what are those big balls looking for? I think there's many ways to dig a hole. In fact, all these big bosses are from the builders. They arrive on site, on private helicopter, and they look into this 2.5 diameter hole, try to find diamond. This is a project in South Africa, I think about 10 years ago. But they can only see a slurry in this 2.5 big diameter borehole. So there's also many different equipment we used to doing this piling or borehole. But this evening, I think I only want to talk about BG, Bauer drilling equipment. In fact, the BG, Bauer BG is multi-function equipment. You can have a lot of different attachments to do the SMW or the continuous fly logger, even can attach the cutter to do the diaphragm wall. But in Singapore or surrounding area, I would like to say 95% or even more, we are only doing the Kelly drilling. What the meaning of the Kelly drilling? It means you use the Kelly bar, and the bucket or auger to dig the hole, to make the piles. Or sometimes you have to install the long casing, and for difficult ground condition or big pile, you may need oscillator. So this evening, I only cover, I call it Kelly drilling system. So typical method used in this foundation technology produce cast in situ bolt pile, for foundation pile, bridge piles, or you can also use this piling technique to make the wall, like a retaining wall, we call it second pile wall. It's also common in the market. How about the pile depth and the diameter with this kind of method, bolt pile, drilling by BGs? I think for the Kelly drilling, normally we talk about from 500 millimeter to maximum about 3 meters. Okay, very, very special cases, 3.5 meter diameter piles, which has also been done in Singapore, the market street. The depth, nowadays, with the big machine, you can go down to 100 meters, or even 120 meter deep by this kind of Kelly drilling method with drilling rigs. How about this application or any problem with different soil conditions? I think for the soil, or less than 5 ampere, I consider the soil, I think the easy part. Then we come to the fracture rock to about 50 MPa. I think UCS here means unconfined compressed strength of the rock. From 50 to 100, normally we call it hard rock. Then from 100 to 200, very hard rock. I think from 100 to 200, normally in Singapore we are talking about this G2 rock already, or even this sandstone boulders. I think the maximum rock strength has been drilled by this kind of method, Kelly drilling by the BG. I would say about 250 or even about 300 MPa. In Bauer's production line, BGs, we have 2 production lines. First, I call it V version. The V version, first we look at the support kinematic system, or we call it the big triangle. What the meaning of the big triangle? I think big triangle can see the support system from the site. The big triangle to support the machine. Because especially when we are doing the big diameter or hard rock drilling, you need very strong support for the machine, the mast, to against the vibration. The support system is not only from the side, and also from the back. From the back. So this big triangle means you have big support from the side and also from the back. This is one of the machines, the BG46 used in Marina South to drill 2 meter even, or up to 2.5 meter diameter pile, down to 100 meter and 105 meter deep. Another production line I call the edge version, or small triangle. If you look at the system, the supporting triangle is much smaller from the side and also from the back. This is from small to medium version of the BGs. I think in the market, we just talked about Singapore. I think we have about 120 or 130 BGs working in Singapore. I would say nearly 99% or 100% are V version, because here we have hard boulder, hard rock, and even very big diameter pipes. So this is show you another comparison: big triangle and small triangle. Again, big triangle not only from the side and also from the back. I think easily to make the examples. But a man or guy stand, I think wider, lower, more stable. Big triangle. Slim, small triangle. Not so stable compared with big triangle. So let's look at this, the BG, the main components. First, the basic carrier. Unclosed, so can move any place easily, and with the engine to supply required hydraulic power. So nowadays, the big BGs, the engine up to about 700 kilowatts. Then we need a mast. Yeah, the mast is connection to the base carrier and also tension to required height to provide enough height for drilling deep pipes. One important thing here is must be torsion resistant, because when you're drilling hard piles, especially the hard rock, reaction, for sure your mast will shake. So this must have to be torsion resistant. Then we come to another key component, KDK, or we call it rotary drive. Rotary drive slides along the mast and to provide required torque to driving the casing or the K bar to drill the pipes. Yeah? So this KDK can provide 500 kilonewton meter torque for pile drilling or install casing. Then we need K bar. K bar is a telescope, either 3, 4, or 5 parts, yeah, extendable, to transfer the required the torque and the vertical force to drill the pipes. Then you also need the drilling tools. The drilling tools depends on the soil or the rock. Then you select the tools. Later I will give more details. Then you need the main winch. The main winch nowadays can go up to 600 kilonewton. It means single line pull up to 60 ton already. Because I think a lot of big piles, I think for the high-rise building or even for the bridge project. Then control system for hydraulic and electronic to control the pile and drilling, and also is a visualization monitor. You can see any operator anytime, you can see the depth, torque, everything's easy to control the whole process. So let's have a few minutes look into the details, how this slurry pile has been done. Yeah. First, for the slurry pile, you need to drive in the top casing. I think top casing, normally you install until the stable ground. Yeah. So this part we call KDK. Yeah. Connect with the casing drive adapter to drive in the casing. Then you start to drill. Of course, the slurry pile, you need some tank or silo to supply the slurry. during the drilling process. This shows how this carry bar works. This is the KDK rotary drive, and this is the carry bar, telescope type carry bar. So you stand into the ground with a bucket. Then here we need to lock it. Why? Because we have to transport the required torque and the push force into the carry bar and the tools to drill the soil or even the rock. After you drill one bucket, 800 or 1 meter, you unlock the carry, then you retract the carry bar. Just repeat the whole process to complete the piles. And during the drilling, you always fill the borehole with slurry. Normally we use the bentonite slurry. One important thing is to have a good pile quality. After you finish the pile drilling, we call it recycling. Because a lot of fine material suspended in the slurry, you need to recycle it to keep the bentonite in good quality before installation of the rebar cage and concrete. So this recycling system, you pump back the thick slurry through this descender unit, you filter out all this fine material, then bring back this better quality of the bentonite, or even you supply the borehole with fresh bentonite. Then you install the rebar cage and do the concreting. I think for the rebar cage installation, you can use the BG, but most of the time at the job site, we would prefer to use the crane because we like to keep the BG busy, always in the drilling work. So after you finish the concreting work, then you use the BG, or sometimes use the crane to remove this top casing, and then you start another piles. So okay, let's look at the main construction steps, how we make the piles. First, you use the CDA, casing drive adapter, to install the casing, or some project, if the casing very long, the diameter is big, then you may also use this top, I call it top viral, to install the casing. Then you start drilling. During the drilling, you always fill this, the borehole with the bentonite. Why I like to show these photos, I think I made last year in JB. You can see two big machines, BG46, very big machine, about 230 tons, drilling the big piles. One is just to start with the auger for the casing installation. The other already drilled down to about 50 or 60 meters with the big bucket. And full of sight is a shit. But please consider, I think for this kind of job, 2.5 meter bucket, each bucket, if we drill 1 meters, we are talking about 5 cubic meter of soil, yeah, and 10 ton. So after a few buckets, if logistic arrangement on site is not properly, this is what you can see. So for the big piles, not only the drilling, I think how to remove all this disposal, all very challenging to the contractors. Then after you finish the pile drilling, this is what I just mentioned, you need to do the descending. Yeah. Descending, you pump the thick slurry from the bottom through the descender, you fill out the fine material, sand, then you keep the better in good condition before you install the cages and do the concrete. Then, after descending the piles, then we lift the cage, normally by the crane, and do the cage installation. Then we do the concreting. During the concreting, the slurry will be pumped back to the silo or the tank. Yeah. This is another same job site. I think that nowadays, especially for this big diameter pipe, 2 meters above, we are talking about 50, 60, even 80, 90 meters, 100 meters. It's very challenging. I think for the contractors, no matter it's main contractor or even pipe contractor, how you do the proper logistics. First, how you arrange to send out this disposal. This project, no hard ground. Every day you can finish 1 pile, 1 machine. It means about 450 cubic meter of soil. So 2 machines 1 day can easily generate 1,000 cubic meters of soil on site. Second, if we look at the concrete volume per pile, we're talking about nearly 450 cubic meters. And how many trucks required? 6 cubic meter truck, you need 74 numbers. 8 cubic meter truck, you need 55. And once you start this concrete process, you cannot stop. So each pile, only the concrete time, you need about 14 to 15 hours. I think this is really the big challenge when we are talking about this big pile drilling. Yeah. So trimming concrete. You finish the pile, we install the trimming pipe, the hooper. Normally we have the rubber ball to separate the slurry with concrete. And you start pouring the concrete. And then pump back the slurry to storage tank or silos. Yeah. Then from the bottom and gradually concrete to the top. Then you finish the pile concreting. And this is the detail. What's the rubber ball look like? And this function is to separate the concrete from the slurry during the concreting. Yeah. We are talking about soil drilling. How about rock? I think in Hong Kong or in Singapore, a lot of the area we encounter the rock, especially with some design purely end barrier. So have to go into the rock. Then it's important to understand how we select the tools or even the teeth for soil drilling and for the rock drilling. This chart shows you the different type of teeth. Start from this type, I call it flat teeth, which work for the normal soil until the rock strength about 15 or even 20 MPa. Other than that, we need the bullet teeth, or we call RSC teeth. Then from about 20 to 80 or 100. Of course, the different type of teeth, you can have different type of tools like the auger or the bucket. How about the rock strength or boulder strength? More than 100. I think either you can find in Singapore, even like the boulders or the G2, or even sometimes G3 or more than 100. Then we need roller bit and even the cross cutter. Even these tools combined to drill into the hard rock efficiently. So, for the soil drilling, we need the tools and the teeth design need high penetration, but you don't need the big force, high torque. Yeah. But when we look at this hard rock, no matter it's a boulder or very hard granite, we are talking about rollerblading. Yeah. It's the key weapon when you are dealing with this kind of very hard rock. This is the hard rock drill in Hong Kong, KCRC. We are talking about, I think the Hong Kong spec is very similar to what you used in Singapore, called the G1 or G2 granite. I think G2 granite can easily go up to 200 MPa. How about Singapore? I think Singapore is very famous for the powdery clay. This is the first project I got involved in the year 2003 as a new project. I still remember first day I arrived on the job site. The customer told me very hard boulders he counted. Then I asked what's the strength. He said about 100 or about 100 above. So after we drill out some boulder, we take go on site and then we test it. I think it's, honestly speaking, it surprised me. The strength up to 168. Of course, in Singapore, we have G3 and also G2 rock. Yeah. And especially G2, we are talking about the strength up to 150 or even 200. So, what's the salient points when we're talking about using the Bauer BGO or piling system? I think it's flexible and easily adjusted equipment, and also with the different tools to drill in not only the soil and also the hard rock. Short setup time. Normally we're talking about 1 or 2 days. You can get the equipment ready to work on site. And the high drilling speed, because high torque and the big winch. And of course we are quite proud of our product, yeah, BG. Then I would like to talk about this, because it's both pile, yeah. During the drilling we're talking about the bentonite slurry. In recent years, a lot of people have started to use the polymer. Why I still want to talk about bentonite instead of the polymer? Because polymer, I think, is good if used in right soil condition. In my opinion, for prohibited soil, up to the fine sand, you are using a polymer, which has the density only 1.0, can stabilize the borehole. But once you have the permeable layer, medium sand, coarse sand, even gravel, sorry, I think according to my experience, polymer doesn't work unless you keep filling. So tonight I still want to talk about bentonite slurry. In fact, bentonite has been used in this kind of work more than 50 years. The bentonite is a special clay, yeah, swell and gel after it's dispersed. Normally we are talking about mixing ratio 3 to 5%, and after mixing you wait about 4 to 8 hours, or the next day you can start using this bentonite slurry. The function of the bentonite slurry: first, to stabilize the borehole during the drilling. Second, the slurry has to remain in the excavation or borehole, not to penetrate to anywhere. Yeah. And the third point, it should be pumpable, yeah, before concreting. And during the concrete, the concrete should be easy to replace the bentonite. Yeah. This is the function of the bentonite slurry. Once we know what's the function of the bentonite slurry, then what's the property required for the bentonite, or what's the property we want to check during the piling process. Here you can see we're talking about density and the filtration, and the sometimes density plus viscosity, and of course also sand content. Again, to have a good pile quality, I keep emphasizing this recycling is very important, because we want to have good bentonite before we install the rebar cage and do the concreting. This is to have a clean base. Then we have the pump to pump the thick slurry from the bottom and we supply the fresh or good bentonite to replace the thick or old starry. And then here you can see all the sand are separated from the working bentonite. What's the spec for the bentonite slurry? Here is the general recommendation from its piling specialist. Fresh, ready for reuse, and very important, before concreting, you have to check the density, viscosity, and the sand content. Normally, if you do the proper descending, the sand content will be less than 1%. Quality control for the piles. Now I would like to talk about regarding the quality control. The items for quality control. It may not cover all, but this is the typical. First, some countries may like to check the verticality of boreholes. For bore pilings, I think normally we are talking about the verticality requirement about 1 in 80. Yeah. Some special cases, we are talking about 1 in 100, but very rare. And most of the cases, not even check the pile verticality. Concrete quality can check the cores. And interface. I think the interface at the pile toy, especially for the rock drillings, is quite common. I think in Hong Kong, they like to take the interface coring. Yeah. And barging or necking can have the sonic test. And the barrel capacity, the most popular, even nowadays, we are still use the static load test. This is the equipment used to check the pile verticality. I think in the past 30 years, even up to now, the industrial standard will be coded the Japanese product. I think also some other brands or even Chinese product nowadays in the market. But to me, I would still like to say this. Industrial standard, please, if possible, still use the coded, more reliable. Yeah. So you have a sensor placed in the center of the piles. You go low down to the borehole, and you have a winch unit, and you can check the pile verticality. This coded can go down to about 108 meter deep. Yeah. And this is the top casing. You can see very clearly from top the casing that you can see verticality. Concrete core to check the concrete quality of the piles. And I think this is what I just mentioned for interface coring. Is very popular in Hong Kong because I think in Hong Kong most of the piles are end-bearing design, so they has very clean contact between the concrete and the bedrock. So this is the pipe. Normally we are talking about 4-inch steel pipe installed with the cages. Yeah, the data can do the interface coring. This I call interface coring. After the proper designing, this is kind of very clean interface can be reached. Yeah, nearly no sediment between the concrete, the pile, and the rock. And I think the slump of the trimming concrete also is very important because we are doing the trimming concrete and we need higher slump. Normally for this trimming concrete we are talking about slump 180 to 200 millimeter. Then also the concrete report to show you the concrete volume versus the depth. So you know the theory, so your ethical volume and also actual volume you pour into the borehole. This is very stable and good mix after you extract the top casing. This one, I think a little bit is sufficient elasticity. Yeah, you can see very dry. This is the rebar cage. I think it's Hong Kong, but recently I also have seen this similar cage in Singapore project. I think it's here, this cage, what I think we have to concern this design of the concrete, the mixed grain size. But I think even you reduce or minimize the grain size to 16 or 15 millimeter, but still not easy to penetrate such kind of heavy density of the rebar. Then you have quality control. The last one, the steel, very popular in the market. We use static load test to prove the pile bearing capacity. Yeah, so for a short summary, the way for a good pile, we're talking about ball piles, slurry piles. First, need good planning, fair contract, the prices, reliable quality contractors, good equipment, can drill not only the soil and also hard rock. Experienced piling team, including this foreman, operator, banksman, and professional supervision, professional quality control. Then you can have good quality piles. So I think after this ball piles, I come to this next one. I would like to have a short introduction of the second pile wall.